How's everybody doing?
Good.
Are the drinks strong enough?
No.
Thanks, Tara. So today we have a really great presentation about Skybase. So let me give you a little history about Skybase and like how it all started. So about at the end of last year, we embarked on a mission to go to hybrid cloud. So we said, hey, we got to build out this environment where we can let developers self-provision on their infrastructure of cloud environments. And because we're an enterprise company, we got to have a private cloud to satisfy some of our enterprise customers' requirements. And we also want to leverage AWS for being able to deploy our new services using our new SOA model. So in the end, we kind of settled on this hybrid cloud environment where we're going to have OpenStack in our data centers and we're going to use AWS. So we're heads down building this hybrid cloud environment for about 4 months, team dedicated to it. About halfway into it, we realized that, well, we have to also figure out how to deploy our software into the hybrid cloud. And up until then, the process was fairly manual. There was like a lot of deficiencies in our CI and CD, and in general, like it wasn't all. It wasn't what we wanted to be when we have a cloud environment. So halfway into it, we said, okay, we're going to build a team that's going to figure out this whole CI CD thing, how to deploy things into the cloud, and completely automate the whole thing. It was all new to us. Some folks had experience, some didn't. After about like 3 or 4 months of heads down, probably like 6 or 7 people just like banging at it, we came up with this glue that combined a lot of open source projects. Kind of cobbled them all together to create a system that's able to deploy both code and infrastructure at the same time, both into private clouds and public clouds, namely AWS and OpenStack. So we're going to start with a short presentation by Tara, who heads up our continuous delivery engineering team, talking about Packmule, which is part of Skybase, and it's a system that combines the application artifacts and infrastructure into one package and hands it off to Skybase to then deploy it into various cloud environments. And Vlad is going to talk about the overall Skybase system, the architecture, and where we're going with it. Our goal eventually to open source Skybase and let the community continue development on it together with us. We don't know if it's a system that will work for everyone, or if it will apply to other companies' use cases. We think it will work for us, and that's why we're open sourcing. So before we start, please promote this meetup. If you can tweet from your Twitter account, SF CloudOps, and tell other people that you're here. Really appreciate it. And we're going to get Tara to start now. You're a warm welcome to Tara.
People are drunk, it's your fault.
People are drunk, they're happy to have known me. Oops. It's nice to see that I've gotten a couple of you drunk a couple of times in a row. Nice to see you back. Hi, my name is Tara Hernandez. I'm the manager of the continuous delivery engineering team here at Lithium. And where is he? Jigar. This is Jigar Joshi, one of my awesome rock star engineers. You can't have him. He will be demoing momentarily. So as Alex alluded to, we have this big project called Skybase, which is how Lithium is going to leverage the cloud. My team has been participating happily with that endeavor, and we have one little piece of it. So let's talk you guys through that. So the old way. So Lithium traditionally has had 2 main products. The Lithium Community and Lithium Social Web product. I had one of my margaritas, I shouldn't have done that. So focusing on the community in particular, it's a ginormous Java monolithic app in Subversion. Resource contention and long turnarounds with our Bamboo continuous integration system. We have published tarballs, which is cool, but the tarballs and artifacts were published to creaky bare metal systems, not cool. Product configs files are maintained separately from our development environment, and in some cases, actually, our developers didn't have access to those config files, which was a bit of a bummer. Monthly release cycles was as good as we can do, and as we know, monthly release cycles now is slow. When I started in high-tech industry, 18 months to 24 months was cool. I'm old, what can I say? And then finally, proprietary tools were used for deployment, which is really unfortunate because we hire new people and they have to have a long ramp-up time to figure out how they have to deploy this thing. Going into the cloud, we settled on a couple of goals for what we wanted to do as a development organization and thinking about things in a DevOps kind of way. So what are the high-level goals? We need to balance the needs of the DevOps philosophy with lithium engineering culture. You can't separate those two things. Culture is important. Developers own their own deployments, but it's unreasonable for every one of them to be experts on everything. The goal of the release engineers, us, and the operations team, Alex and company, is to build the tools and the pipelines that dev resources are used most effectively. And despite claims of people at previous meetups, I'm thinking Chris McGowan, I don't think he's here tonight, unfortunately, the role of infrastructure and operations engineering is not going away. And in fact, I think it is getting a lot more interesting. So he's wrong. Sadly, he's not here for me to tell him that. Plug and play. Oldie but goodie from the 90s. Who here was in high tech in the 90s? All right, old people. So there are a ton of different technologies, utilities, helper apps, you name it, around the cloud. Many of them have only been written in the last year or so. You guys have noticed this, I'm sure. The robustness is amazing. We're building our own system with an eye to being extremely flexible, leveraging what looks good, but making it really easy to pop out if something else comes up that's better. Or if we need to, we can write it ourselves. And if some teams want to actually customize it for their own specific needs, that's okay. Be fast, okay? This is fast, right? Cloud is fast. We want everything to be fast. The ideal scenario is from developer to customer in a matter of hours. Okay, some people I've heard claim minutes. I think that's ridiculous. Hours is good, especially if we're talking right now about a month. Everything about this system has to be fast. In particular, the automated validators, builds, tests, etc., need to be really fast. And right now we have tests that collectively take something like 24 hours to complete. And that's got to change if we're going to have the same level of test coverage and actually have that be an automated gate to the deployment process. And then the last one, which is very important, especially in light of this meetup, work with the larger community. My team in particular are engaging with various open source projects, specifically around the development environment. So Test Kitchen, Berkshell plugin, Berkshell Vagrant plugin, Jenkins Stash Notifier plugin, 9PC2 plugin. By the way, if any of you have contributor collaborator status on any of these projects, please review our pull requests. We're waiting. And we'd love it if you would look at them and approve them. And if you know somebody who's a collaborator, please kick them to look at them and approve them. Many more projects will likely pop up and become important to us in the future, but we have only so many resources to spend our contributor dollars for open source projects, so we'll have to kind of figure that out. But from a development perspective, engaging with the open source community for cloud development operations is, I think, absolutely critical to Lithium's success in this field, so we'll continue to do that as much as possible. By the way, I'm talking a little fast, aren't I? Sorry, shouldn't have had my margarita. The new way, okay. Talk about the high-level goals. Here are some specifics of what we're trying to achieve, again, from a development perspective. No more subversion. Everything is handled via Git, project repos, coupled with a dedicated Jenkins instance. So, again, we went from going big Java monolithic apps and subversion. Now we're going to be a platform of services, a SOA model, if you're familiar with that. And so we have to change our development environment to fit this new model of deploying. So the development environment, we use Stash. We pair it with a Jenkins server that's provisioned by Chef. Currently we're using AWS for these resources because it's easy. I know it's expensive, we'll worry about that later. The workflow we use is very similar to how Garrett works. However, Garrett turned out to be a complete pain in the butt to install in our environment, so we gave up. and instead are using Stash plus Jenkins to basically replicate the same behavior. Liberal use of idiot proofing. I will come back to this. Leverage third-party tools where possible. Don't reinvent the wheel. That said, there are so many wheels rolling around these days, it's hard not to reinvent some, and sometimes you just have to kind of roll your own. We're aiming to limit such work to where we truly need it and emphasize using open source and commercial products where we get the best bang for our buck. Ideally, most of our engineering efforts are going to be around implementing the glue that ties all these different pieces together. Again, we're going back, we want plug and play for some of these solutions. We want to take pieces out, put new pieces back in. From a pipeline DevOps perspective, we want to get to the point where as developers, we can check in our app code, check in our cookbooks. The pipeline will carry everything down the pipe all the way to production until it's out the door. We may not be able to do this for absolutely everything, but it'd be really cool if we actually had some services that literally went from git commit to customer facing without the touch of grubby human hands. That would be cool, that is my goal. And in fact, if I don't complete that goal, I may get a slight ding on my review this year. All right, let's talk a little bit about what I mean by idiot proofing. I'm an idiot, so it's proof against myself. Idiot proofing that is, make it so that it's hard for a tired engineer who has been working very hard on many different things to make an ugly mistake. It's not actually that we're all idiots, but we get tired and we can make mistakes. How do we not make mistakes? Automation as much as possible. So developers may be responsible for the ultimate deployment of their software in the DevOps philosophy, but they shouldn't have to do everything themselves. Okay? The right tools should be provided to make it easy for them to succeed. So standards. Standards means something very specific in this case. There are so many possible moving parts. We want a foundation to base everything on. So standard VM images, for example, that we can use in any format, VirtualBox, VMware, OpenStack, EC2, same image is one great example. Management of development tools, Chef, Knife, Bundle, VM, all these things. Turns out that's actually a hard problem, especially if you're splitting between OS X and Linux. And if your Linux is a VM and a VM. Everybody see conception? A VM of a VM of a VM, it's really slow. Liberal use of pre-received hooks. This is a favorite of mine. Pre-received hooks are cool. It's one of my favorite features of Git. This is why I like Stash over GitHub. Now I know there's GitHub Enterprise. I'm sorry, GitHub Enterprise is about 5 times more expensive than I am willing to spend my company dollars on. Stash is awesome, and it's cheaper, which is a weird thing to say about an Atlassian product. But we're an Atlassian shop, so we're used to them, and it actually is cheaper. And hooks, I mean, fundamentally, make it so we can catch whether or not you accidentally included an unencrypted AWS key in your code. Don't do that. If you accidentally checked in a modified community cookbook that accidentally only works correctly on Ubuntu. Did I mention that we're a Red Hat shop? On the development side, the focus is, before we even start committing changes to the master, we should know whether or not it installs and runs correctly by use of local tools, so you don't have to talk to the cloud at all. You can use Vagrant, VirtualBox, whatever. From a project management perspective, it's stopping bad code from accidentally hitting the master branch and taking out the whole team because they did a git pull before you realized, oh crap, I just checked in something really wrong. We want to prevent the egregious bugs from getting deployed. We want to easily pair the app with the configuration management that goes with it. We want all of this to happen as easily as possible. Right? Focus development on what they're good at. On the operations side, we want things like monitoring, alerts, auto-scaling, other sundry things that are going to help us manage our deployments, again, in that DevOps philosophy. All right, here's a little picture. Basic structure for the developer's main existence at Lithium, or our intended main existence at Lithium. We're still rolling this out. It should look pretty familiar to most folks. It really is, this is a Garrett model, but we're not using Garrett. And the same model can be applied to our application code, to our cookbooks, to any sundry tools we may be developing. Same idea, we can use the same tools, provide consistency, and again, going back to that standard where we have a foundation that we can build on that works. Here's a scary picture. So that last picture was sort of the first piece of what is the overall process. Vlad is going to go into this in much greater detail. It's actually more complicated than it actually is. Vlad, don't make me a liar. And this is what collectively is known as Skybase. And this is going to make Lithium awesome to our customers.
Lithium is awesome to us, not to our
Well,
customers.
it's going to make lithium more awesome
Okay.
to our customers. Okay. And the main thing that I'm going to touch on for my talk, and Vlad will touch on it too, is the most important thing about this whole process is that the implementation of the pipeline itself is not the most critical thing. It's what goes in and out of the pipeline that's going to be critical. So for our team, we have the pack mule. So this is a pack mule. I've met people who actually don't know what a pack mule is, which means they are not familiar with the history of the American West. Third generation Californian, I'm all about the cowboy. So previously, monolithic Java app, artifacts went to Nexus, this extremely primitive, oh, is it the 1980s tarball, went to a disk server, and then there was operations team which was stuck with taking the tarball and deploying it to various servers and being sad. We don't want a sad operations team. Instead, what we have is the Artiball. Vlad's going to talk about this more. But so if you think about what the devs used to do, write some code once a month. My team would package it up. Actually, we still do this, but we're going to stop soon. QA would test that for a week. And then operations would laboriously deploy it to all of our 400 and humble customers and be angry. Configuration management information for the product was stored in a completely separate place from the application. Sometimes there were challenges, and in many cases, developers couldn't even see the configuration information because they didn't have access, because it was in the production sphere. This is bad. This is not DevOps. So in the new world, we have the Artiball, which contains everything needed to provision a new instance in one unique place. This is very important. It includes an RPM package for the app itself. Again, if you're a Red Hat shop, you can use RPM. Not that I'm against app, but I like having fun. We've got templates that are translated into CloudFormation or Heat or whatever cloud vendor that operations has deemed us willing to deploy into. Configuration information for the app, which is now stored with the app and not in some separate service. And then the cookbooks themselves that are necessary to complete the provisioning and the installation. This collections of things is now what gets tested and used all the way up the pipe, hopefully in as automated a way as possible. Again, we want to go from check-in to customer in a matter of hours. This is our sky, blue sky. The system is intended to be very simple. Our part of it is a very lightweight Python app with some classes that describe the elements of the Artiball and some methods that allow us to manipulate it in some interesting way. Not a lot of code. You can totally use the back end, which also has a command line interface, without the front end, as long as you know what you're doing, which many people do. And there are great reasons, like sales, assistance, demos, that kind of thing, where you want to completely bypass everything and still deploy to some cloud instance. And then what the front end buys you, which we're currently writing in Java, is the idiot proofing. Okay? I'm big into idiot proofing. You supply the information necessary to make the Artiball, the Git repository URL for your deployment templates, your application configs, anything else that might be relevant. Jagar is going to walk you through the demo. It'll automatically handle pulling those down, bundling them, generating the config information that is necessary for the rest of Skybase, and then pick up and do something useful with, and then publish it out into currently S3, but it could be anything in the future. And then if there's a problem with that deployment for some reason, we have that separation of church and state, we can go into our Jenkins log, which is how we're reflecting that front end primarily, extract the exact command that was used, and then run it manually if we need to. No fuss. We don't want a fuss. And Jagar is now going to show us a little bit about how that works.
So, Packmule is a tiny Python tool that just writes application package, config, deployment templates, and the inputs together, and it creates a simple file that Skybase will consume, and it will create the full environment and the application deployment based on just this single file. So this is how I created a simple Jenkins plugin on top of this tool. So I'm just going to demo this thing. So the lower portion is the Jenkins log, and the upper portion is Jenkins UI. So we created a Jenkins project. I'm configuring it.
This is a very thorough demo.
So assume that this commands will generate the application package, it will compile, test everything. Then after this, the package will comes with the thing. Here you configure the project application name, version, package, where the package file will be, what the package format will be. For example, it could be tar, it could be jar, it could be war, anything. Where you want to deploy, for example, you want to deploy to S3, you want to deploy to your custom, like hard server or something. This is the application configs. So the deployment templates that you're adding. And the application cookbooks. The cookbooks that application needs to provision the environment. And now it's building the project. So here you can see the package is being executed and executed successfully. It ran the success code and it created the bundle at wall and it deployed it to the S3 repository. So under the hood, it validates all the parameter. It checks the file size, file type, file content. It does the cookbook download, cookbook install, cookbook packaging thing, and it creates the final bundle and it uploads this to the deployed location that is specified. In this case, it was S3. So this is how it works. This is still in very first phase, like very basic phase, but this is how it's going to be working. Yeah.
Questions? First luck. You're up.
Yeah, my laptop is long back.
Where's Gary?
All right, time for another drink.
I'm going. I'm going.
So, I mean, I'm not as a good speaker as Tara, so my apologies in advance if my talk will be a little bit. Yeah, that's all. So I'm apologize if the talk will be a little bit boring, but it's a lot of stuff to discuss. And I hope there will be a lot of questions afterwards. So my talk is called Skybase Finding Your Way in Hybrid Clouds. And this talk is not about science fiction. It's more about software project, but not exactly. It's mostly about finding a way to simplify a complex situation and create software to bring order out of chaos. As Alex mentioned before, Lithium is moving to hybrid cloud and adopting DevOps model. After trying different tools which are out there and approaches to develop automated pipelines, we still realize that there is something missing, and mainly it's where glue or adapters between different open source projects which can be used to automate different portions of a complete pipeline. So for this reason, Skybase project was born. A little bit to describe the situation which we have. We are software as a service company. We have 400 plus enterprise customers. Currently, we're moving to hybrid cloud. We are establishing continuous integration and continuous delivery processes, which is not straightforward and not easy thing to do. And we're adopting DevOps model. At the same time, we are running full speed with our current business and adding new services and for existing applications which we are currently running for our customers. To describe a little bit what we are dealing with in our current production, we have two main applications, which is community services for different companies and social web for also different companies. Out of these two major ones, we have several independent applications which are add-ons to existing pieces. And each of, let's say, for different customers, the versions of the software might be different. At any point in time, different customers might run different versions of software. Why I'm mentioning it? Because when you hear about automatic deployment pipelines, people usually talk about simplistic model like dev, QA, prod, and you have one app which you have to move between these three environments. So on top of, and then if you have inside these environments, you have several teams who are developing and deploying their software into the same place, there is a chance that they will step on each other's feet. So we have to come up with something which will provide platform for DevOps teams to do their work without bumping into each other. So essentially, as you know, one of the challenges in this case is not only to find the common ground between different services and how to deploy them, but also convince different developers what is the best and standard way of doing things, which is usually referred to as herding cats. So we are kind of doing this. Essentially, old style ops still have a role inside DevOps model. And what we are doing now is we're creating the infrastructure platform so this DevOps team can maintain their own services. And among other things, this platform has to include pipeline, but it's more than only just pipeline. There's a couple of other things which you have to add to create a complete DevOps platform. So how deployment pipeline might look like is on this slide, which I already showed you. But the main point here for now, at this point in the presentation, is in the middle is the deployment pipeline itself. On top, the orange blocks are actually groups of servers which perform and used for different actions and for different purposes, like dev. VPC is used for, dev environment is used for developers, individual playgrounds, and all this stuff. Then we have a continuous integration environment, which is used by automatic testing system, which Tara is building. When it goes to QA, where we have some automatic testing and some manual tests. Usually in this type of pipelines, what happens is after developer checks in the code, it automatically gets promoted to continuous integration where automatic tests are run. When pack mule creates the bundle, artiball, and that is deployed to QA. After that, it has to be some approval gate, say it's okay to go, and QA has to tell. After that, we can move to user acceptance, staging, and then production. As you saw on this slide, as you saw on previous slides, our situation is somewhat complicated because of multiple services which we have to deploy and multiple teams working in the same environment. So we have to come up with something and a little bit different approach, and what we have to consider is how fast we can transition, because when you run old system and new system, it's very difficult to switch. Sometimes it's easy to stop everything, convert, and start a new system. But in our case, we cannot do it, and we have to accelerate somehow. Fortunately, we have two teams who are working on this pipeline. It's like Tara's team coming from dev perspective, and our team comes from ops perspective. And we will have to meet in the middle to create a complete pipeline. So after that, we have multiple different places where to deploy it. We have multiple physical data centers in San Jose and Amsterdam. We have hybrid cloud situation when it's OpenStack, private cloud, or it's public cloud in Amazon. And if we have all these environments created manually and differently, then we will be dead just to maintain the different configurations for all different environments. So definition of standard target location for deployments is the only way to simplify the configuration management as we see it. Another problem with establishing new processes is to finalize what is the workflow for deployment. Let's say in the deployment pipeline you have dev, QA, prod, but sometimes what we have, and we have to have, because we provide customers, for enterprise customers, we have to have compliance environment, which is essentially security tests for the environment. We have also performance environment testing. So essentially we have multiple environments, and this might be changing depending on the business needs and some other, mostly the cost considerations. So what we're doing, we're decoupling the development of deployment into one location from the workflow and business logic of how you sequence these deployments inside the pipeline. So this is decoupled. So at the end, after this whole meditation on this subject, we come up with two new concepts, which is artiball and planet. So what these things are is, let's say, what is artiball? So this is what I'm talking about. Continuous integration portion left side of the pipeline is dropping the artiball and into continuous delivery or deployment, and then it deploys the artiball to the planet. Actually, artiball stands for tarball of release artifacts, and we cannot claim that first time using it. We just borrowed this term from a guy who got his name in Chef Conference in San Francisco last month. But the idea is the same. Essentially, you pack not only your application, but environment, how to install it. Simply, you pack application code like RPM or something, and application configurations for all places which this tarball might go. When you have recipes and cookbooks for configuration management system to install these packages and configure them. And the difference from the standard physical deployments, this article has to include deployment template, which is description of resources in the cloud, which will be created for this particular service to run. So why we talk about planet and not environments? In old style, simplistic way, we have called environments dev, QA, stage, prod. These were environments. Now, when we go into different clouds, and we have Amazon Cloud, we have OpenStack, Open Cloud Systems, OpenStack, Private Cloud, and we have several data centers around. So when we talk, we found that just using the word environment becomes confusing and ambiguous when people talk about, I want a server in QA, which doesn't fit to the situation, because in which QA? Is it Amazon? Is it Amazon in US? Is it Amazon in EU? And which region? So essentially, we decided that unit of deployment target would be intersection of development purpose and cloud provider and one region. So if you have North Cal region Amazon used for dev, it means that it will be dev AWS North Cal planets. So we come up with them because we have different, historically for lithium we have terms like galaxy and all that space related stuff. So we call the purpose now, we will call universe and cloud provider and the planet. So the complete, to position your server or your service into our infrastructure, you have to specify what the purpose is, specify universe. You have to specify what provider you are requesting, which is AWS, and you have to specify which region. This fee will define and place your service exactly and unambiguously. So this is the reason for introducing new term, which you have to get used to, but after that there is no misunderstandings of it. After we define how we will call planets, we have to define what this planet is and what it consists of. So standard planet, for instance, dev AWS US West 1, which is North Cal, is a VPC, which has assigned support services to it, let's say YAM repository, S3 buckets used by installation, DNS services like Route 53 or DNS Made Easy. In our case, it's Route 53. Then some monitoring services to monitor this service, and common logging services like Sumo Logic. In addition to support services, the standard planet contains the configuration management system, which is, in our case, Chef server for reasons we can discuss, but I mean, we already gone this way. There are different choices to do configuration management, like Chef, Salt, Ansible, but in Puppet, but we standardized on Chef. Third piece of standard planet is the Cloud Control API, which is API for cloud provider. So it's the OpenStack API or Amazon API. And then after that, in our standard planet, you deploy service as application stack, which consists of multiple types, different types of servers and resources from the cloud. After we define the article and define that we have standard planets, the description of pipeline reduces to the statement that deployment pipeline is a sequence of single deployments of articles into planets. And business decides the order of the planets, how to arrange them, mix and match and whatever. But from development perspective, implementation of a Skybase and deployment pipeline core is deployment of one article to one planet. After that, it's very easy to build on top of that. Now, each deployment of article into planet, no matter what you do, and actually it's not even about planet, it's regular service deployment into any production environment, to any environment. You have to prepare support services. You have to prepare internal DNS for it. You have to prepare YAM repository if you use RPMs to install. You prepare like local NCP servers, whatever support services needed for your application to run. After that, you have to prepare Chef server in our case, but you have to prepare configuration management so it will be ready for new instances to come up, and where configuration management will finish the job installing the application configuration. So, but you have to prepare Chef or any other configuration management before you launch the instance. It might be different ways, but I mean, it's still the same step. When you launch the instances and point them to Chef server, which is supposed to manage them afterwards. After the instances came up and the application is up, you don't direct, let's say in production, you never direct the traffic to this new service, newly installed version immediately. You have to do smoke check, which is like common sense, but sometimes people forget about it. And after you verify functionality, when there is decision making, you don't do it automatically. The last step 5, which is redirecting traffic into this new version, it's after approval gate and it's separate click of a button. So now we discussed the concepts and our approach and definition of the situation and what is this thing about. Now let's talk about Skyline, Skybase itself. But before we start talking about the pipeline, automated pipelines, I'd like to tell a small old joke. So, I mean, Hajjana Sredin said that there is no wrong way to ride a pack mule. No, I faked this quote. But real story. Real story from 15th century was that Hajjana Sredin was sitting on the market and 2 men came to him and said, Hajjah, could you help us to resolve our dispute? And Hajjah agreed, and first man says, I think that this thing has to be done from right to left. Hajjah says, you're absolutely right. Second man says, no, this has to be done from left to right. And you're absolutely correct, said Hajjah. It was a bystander who saw this thing and says, Hajjah, it's impossible that both of these men can be right at the same time. And you are absolutely right. So this reminds me, if you talk to Ops-Code or other configuration management vendors, if you say, can we deploy and create the pipeline using Chef this particular way? They say, yes, you can do it. If you say, other person, your coworker says, can we do it different way? Yes, you can. So essentially, no matter what you do, I mean, the vendor will not disclose recommendation about best practices for the deployment pipeline. So here are 4 truths about this. There is no single universal way to create deployment pipeline. Yes. Tools gives too much flexibility to users, which causing actually confusion and paralysis by analysis. It is possible to create deployment pipeline to be useful for many companies, and Skybase is the way to do it. Yay! So in development of Skybase, we choose several design principles and technologies. Minimalistic user interface, less options, but implementing standards which are defined in flat files, so you can use standards. But in normal day-to-day life, you use a couple options and that's it. So it's like stupidify interfaces and remove all flexibility. And because, like in Amazon, there is best practices. You have public subnets, private subnets in all 3 regions. They don't create you this as one click, so you have to every time build it yourself. In our case, we say every standard plan has 3 AZ, 3 availability zones, and public and private subnets. So 6 subnets for VPC, and there is no way to change it. So for configuration, we use Chef server, which has one limitation, which is Chef client always uses the pool model, so you cannot. It's more difficult to do orchestration when you have to synchronize or do one operations after another. So for orchestration and remote execution of stuff like simple troubleshooting, we're using Salt from Salt Stack. Even though Salt can be used for configuration management also. For historical reason, we already invested a lot of time into shared development, so there is no reason to switch. We're missing only one piece, remote execution, which is done by soft. Our framework is written in Python, just because. And one advantage here is that even though we say that we do standardization and we can use templates, we still allow full flexibility of CloudFormation template in Amazon. So we use the YAML file with data which are specific for particular, say, planet subnet IDs, AMI IDs, and so on stuff. And we have Ginger template describing the CloudFormation template. If you use CloudFormation templates, it's very cumbersome to use the syntax for defining parameters, for mapping functions like join, whatever is inside CloudFormation template is gone. It's done outside. So essentially, we have data and we have resource description from CloudFormation template. We merge them, and this it becomes the CloudFormation template which gets deployed. So now it's the same thing in terms of how many steps, because we have to define what steps needs to be done, and we divided them in five groups. These are fundamental steps which have to be done no matter what. In our case, you have to pick up the application release. In our case, we're picking up Archibald, which has application configuration, install recipes, and deployment templates. After that, we pick up the configuration of the planets from the database, and we check for existence of other dependencies if we need to from the state of the planet. Then we prepare the support services, we update the share server, and we prepare and launch CloudFormation template, which creates the instance pointing to share server, and share server finishes the installation. From the code architecture, the Skybase core consists of several pieces. We have client, REST API client, which talks to web app, which essentially maintains the queue and provides authentication for the clients. After that, each request is going to one worker which uses the Skybase library consisting of classes like Archibald, Planet, Sky, Candy, which actually performs the actions on the planet. So this model allows us to add different connectors to outside system from REST API, because by adding new worker, we can provide different connector to different services. So now, demo will be like 3 seconds. But what I'm trying to do is, if you work, and currently our developers have to demo the deployment of Tarball, prototype of deployment of Archibald into the planet. Currently, for instance, if you use Knife EC2, what happens is you have to set the parameters of the planet into Knife RB file. If you want to deploy to a different planet, you have to replace Knife RB file, configuration file for Knife itself, and then you do Knife EC2 create service, which is the same, but you don't have to do it. What happens is, what we can do is, we have pre-configured different planets. Oops, sorry. I'm watching this.
We can't see anything on screen.
Yeah, just big. So we have pre-configured planet, which operations usually define ahead of time, so developers don't have to know what is the subnet IDs of different planets, what AMI ID to use. Essentially, everything is inside the planet. So developer usually say inside the deployment template, say, I need this size of image, instance of M1 extra large. this is enough, and then they say, I need standard Linux. And we don't provide many AMI, we standardize our CentOS, so we have our own CentOS package, and this is the standard. So you don't have to specify multiple options inside the template. It's all provided by deployment configuration, which is maintained by a different group out of developers. Now, and this one creates like once a blue moon. Once per year we create a new region in Amazon and stuff like that, but it's not every day. What happens? Artable are created by Backview, and we have multiple of them. So what we do now is the same as Knife EC2 create server, but with pull-down menus, and you don't have to worry about your Knife RB files. This is, it will be dry run because I don't confirm creation of step. So all what it's going to do is to pick up YAML file data for Blend, pick up YAML data for the deployment template, merge them together, and create CloudFormation. So this is the CloudFormation template, which if people use the CloudFormation before these resources, screenshot resources, there is a bunch of stuff like mapping, parameter, entering parameters, and all that stuff. And after that, there is a lot of join, wizard stuff, which comes, like for instance, here we have a small example, like this is what you do if you want to add 2 lines of code. You say user data, then in Coinbase 64, and then function join, and then you join strings with end of the line inserts there. So but what the Skybase did, it simplified your creation of CloudFormation templates, that new developers to cloud were not scared of CloudFormation templates. Otherwise, instead of 1,000 lines of CloudFormation template, you have 5, and plus you don't have to do it anymore. So now if you'll do the, to show that
that just returns the JSON.
yeah, and we put JSON to Amazon API. So just to be sure that I'm not lying, that there is no steps. And it returns us ARM ideals. So now that thing is supposed to create in progress, and so just to do. So it goes to different resources like security groups. Yes, Alex worked me about live demos.
Jeff Bezos' fault.
I guess I can continue with the demo. The return package should be created. So it's not us that say that, it's Amazon.
It's an alpha plug, right?
Hmm?
It's an alpha version.
No, I mean it's.
Yeah, there you go, create complete.
Those great.
Yeah, but it's just one resource, it's just only one resource. So the security group, but instance doesn't want to start. Yeah.
There we go.
Yes.
There we go.
And for normal developers, they don't like UI, so what we have also is so we go, and I'm not going to type, I will, oops. So this is command line saying Sky deploy single server into Planet Dev AWS, the Skybase, and this time we'll say that it's dry run because it will have, it cannot create step second time because we didn't change it. So we just create the same thing as if you say, supposed to say that it's the error where resource already exists. It's the same as we do here, and we relaunch this thing. It will say that already exists. So, So if we do this demo second time, it should say error out because step already exists. This was all for the demo, and so conclusion for this talk is that decoupling of continuous integration, continuous deployment helps, and we're using RT-balls for doing this. Defining the standard planet will greatly simplify the configuration management. And in real life, you don't really need all these choices which Amazon gives you to do. You can stick to one good best practice for your company and continue. And with fundamental steps to prepare support services, configuration management, API, these steps are there no matter what, and even though you can change chef by salt, this Skybase you have to change only one function. And finally is to say that Skybase is the glue to glue it together. So future of Skybase platform is adding more fancy stuff and more useful and simplification in front of it. Using ChatOps, which is essentially sending REST API requests from the hip chat using Skybot, which is based on Qbot robot. When adding new connectors to external RESTful APIs like Jira, when we can trigger the deployment by submitting ticket to Jira, and it will trigger the deployment. We have prototype of this for deployment, product deployment request services. And it can receive alarms from monitoring and from cost analytics if you run over the cost of a particular planet. After that, creating of a workflow service is ability to combine predefined existing actions functions into any chain you want to create different workflows, different pipelines for different purposes. And we are targeting, we intend to make this project open source as soon as we stabilize the layout of the code and have something running and useful by a couple of our teams inside. After that, we'll go open source. So but we can use contributors. So if somebody interested can talk to me after the presentation. So Skybase from Dr. Tools.
So how do you know what the output is after the successful after you create a new stack? How does the
you can query API. You can query the Amazon API for the status of all these events. You can take from there.
Sure. So that returns all the resources that were created.
Yeah. It essentially returns all the events which it goes to. But you have to query. For this reason we have web application is one, but workers are separate. So workers found for one request and it will monitor the thing. So it's not the main web app sits by doing this, just worker one. And then it reports back to Skybase, this request is executed.
Hey, it was previously said that this glues a bunch of open source projects together. I was wondering some examples of what those open source projects are and if they manage any testing.
No, I'm not saying, but for instance, we are not implementing server-client communication using SOAP. So this is open source. Chef, we can't use Chef Enterprise, but it's better. We can use essentially open source Chef or Chef Solo development. So it means that big tools like that we pick up from open source.
So you're not wrapping up any existing open source inside of their
No.
computer system. Okay.
We're just using API to talk about.
All right, I got one more question. So in the CI process with like deployment and like integration with the deployment, do you have the same tests run like after deployment and right after CI, and the same thing triggering them, or do you?
Smoke test is a little bit different. I mean, CI testing is more comprehensive than smoke test.
Okay.
But this is defined by QA who does manual testing anyway. So I mean, as a QA person has to be comfortable to release a new version into production, even if it's bad. So we can run their own tool which is outside the scope of Skybase. We might have some, essentially, here to think, one deploy is one thing. Change the traffic is predefined actions in Skybase, but it's not automatic.
So you create party wall, and before you have that, you have testing.
Ah.
After you deploy that, you have another layer of testing.
It's a little bit, there's like dev testing is by itself, but when you, from the build system, you can create article and deploy it and continuous integration testing, done testing there automatically. So the same mechanism to deploy as soon as you have, it's like release candidate article. So you have release candidate and then to cache goes already publishing of release candidate to cache. And but after that Skybase goes. So the testing of article can be done before packaging or with packaging. But it's so it's decoupled. So your testing is separate from the deployment.
I think they're asking about once you deploy an article in production, how do you verify?
That is the smoke test.
Right, so it's,
And it's different from what goes in continuous integration.
okay.
It's subset of the tests in continuous
But it
integration.
is maybe a good idea to repeat more comprehensive, or the same testing once the article is in production.
I mean, like if you deploy update in the database, you cannot drop the table, something like that. I mean, you cannot do full tests in the production. Yes.
So in our environments, we have something kind of similar where we have both manual and automated testing once we go to QA and staging and production. And that's usually where we kind of get beyond that a little bit because it's communicating when all of the services have been promoted to the different environments to the interesting parties.
Yes.
So how do you guys notify like QA and managers
I mean,
what release is actually on each environment?
I can say only about ideal case varies, but essentially this is central location, so everybody using it. So ideal case when we have Hubot, and this is bot which runs in HipChat. So that can handle the approvals and so on, and we have separate chat room for Skybase which will report all the steps. And you say deploy something, it says no, it has to go for approval for a particular person. That person gets email. So, any more questions? Yes.
So how do you deal with resources in AWS that might not be available or are contingent, like availability does not be able to handle new instances or certain resources that might be unavailable at that time? You just back off the whole build and convert all your resources you've already built?
Yeah, I mean, but the difference is like we are not using straight APIs, raw API. We're not using bot. I mean, bot we're using for CloudFormation. And if you use CloudFormation template, that handles everything. So we have true or false situation. If it fails deployment, if stack fails, then the reason would be mistakes in CloudFormation or availability of resources, which is kind of would be strange for us. But if what you're talking about, it would be very frequently situation if you do launch the instance through bot itself and wait until it's done and so on. We're using CloudFormation templates which wraps all this for us. And if it fails, it undo all this resource creation. So, now then. going to, sorry, that's not completely end because I lied. Yes, Alex was going to present maybe bigger picture.
But wait, there is more. There's more to this. So we started this project as a continuous deployment delivery system to deploy infrastructure and code. Then we thought about, well, what if we make this a single platform for DevOps, where you're not only deploying code, now you also want to understand what's going on with your code once you've deployed it into various environments. And what is the, we're all in HipChat anyway all day long. We're talking there, collaborating, wikis or collaborating through forums is not as effective when you're doing live infrastructure administration or you want to know the status of your build. So we thought about connecting Skybase through Hubot into HipChat, so now you can go into HipChat and also do troubleshooting of production issues. Or you can find out what is the status of your build by just asking the bot. Or you can do a lot of other things in regards to infrastructure administration. You want a new instance, you want to launch a test instance, you want to deploy a particular stack. You should be able to do all that through a chat interface where you can collaborate. You can talk to the bot can do things for you, and whatever you're doing is visible to the rest of the organization. Other developers could be in the same room seeing what you're doing. So that's one use case. The other use case that we thought of is what if the bot could actually solve the problems when there are problems during nighttime in production? What if the bot could automatically do troubleshooting and investigation and report all the results back into the chat? Wouldn't that be useful when somebody gets paged, and by the time they get into the HipChat room, all the information and status of the servers and the network is already pasted into HipChat via trending charts, and the bot was able to do a certain level of investigation and troubleshooting, or even trying to fix the service via predefined steps. So for that, Vlad talked a little bit about a workflow service, which is part of Skybase, and there are two concepts. One concept is an action, something that Skybase can do on behalf of a chat user. So Skybase can deploy a build. Skybase can deploy a particular stack into Amazon, for example, or into OpenStack. But what Skybase can do also is it can react to events. And events should be coming from something like Datadog or from Cloudability, which is the cost tracking system for various environments. So if an event in Datadog said that a particular service is down, Skybase can execute a reaction to an event and do a certain level of troubleshooting, and then spit that out through Hubot to HipChat. So like I said, if there's a problem, instead of going to PagerDuty and paging somebody, an engineer, to get online and start troubleshooting the issue, Skybase will do some of that automatically and produce all the results back into HipChat. So we think that's kind of like the true DevOps model, where everybody's collaborating. There's full visibility into everything that's going on through a collaborative chat interface, and this will eventually replace. I think it will eventually replace any need for a web UI for doing any kind of operations, whether it's deployment or infrastructure management. So that's the thought. It's very far away from being a reality right now, but that's kind of where we want to take Skybase, and we're hoping to get contributors. In 1 month, we're going to open source this.
1 month? I didn't say 1 month.
Yeah, so sometime, maybe by the next meetup, we'll have something that's on GitHub, and other people can contribute to it. We also see this as a framework for doing operations. So you'll have your actions, which are basically Python classes, and you have reactions, and everybody, engineers and Ops folks are all contributing kind of to the same system of building it up to deploy and also manage infrastructure. So thanks for showing up. There's going to be a raffle after this for the prize, which is a smart watch. So everybody has raffle tickets? Yeah? And if you tweeted at SF CloudOps, you could have gotten more tickets.